Hi, in this video we look at how to rationalize numbers that have a imaginary or a complex number in the denominator. So if we have 15 over 4 minus 2i, our objective is to write 15 over 4 minus 2i such that it has a real number in the denominator rather than a complex number. So in the last few lessons, you might have remembered that if I multiply an imaginary number a plus bi by its complex conjugate, so this is called a complex conjugate, a minus bi, well, that's equal to, if I expand that, I get a squared plus b squared. So here, if I multiply both the numerator and the denominator by the complex conjugate of 4 minus 2i, well, in my denominator, I'll get a number that's purely real. So let's go ahead and try that out. So let's multiply the numerator by 4 plus 2i, which is the complex conjugate of 4 minus 2i. So I've got 4 minus 2i times 4 plus 2i in the denominator. Now let's go ahead and expand. Well, if I expand the numerator, I'll get 15 times 4, which is 60, plus 15 times 2i, which is 30i. In the denominator, I'm multiplying two conjugates, so I'll get 4 squared minus bracket 2i squared. So in the numerator I have 60 plus 30i, and in the denominator I've got 16. Well, let's actually do this. So we get 16 minus this squared applies to 2 and I, so I'll have minus negative 4, because when I square I get negative 1. When I square 2, I get 4. So we're just going to subtract negative 4. So this is equal to 60 plus 30i divided by 20, because 16 minus minus 4 is 20. Now if I look at this, both the numerator, the two terms in the numerator are divisible by 10, and 20 is also divisible by 10. So technically I could common factor out 10 and then divide out a factor of 10. So this is equal to 6 plus 3i over 2. Okay, next we've got 2 plus 3i over 5 plus 2i. So in this example, again, we're going to try to simplify by rationalizing the denominator. So again, I can look at the denominator and say, what's the complex conjugate of the denominator? Well, the complex conjugate of the denominator is 5 minus 2i. So I multiply both the numerator and the denominator by 5 minus 2i. And if I do that, well, I've got to FOIL the numerator, so I'll get 2 times 5. And then I'll get 2 times negative 2i, which is minus 4i. And then I've got 3i times 5, which is positive 15i. And then I've got 3i times negative 2i, which is positive 6. In the denominator, I get a difference of squares, because I'm multiplying conjugates. I get 5 squared minus 2i squared. Well, 10 plus 6 is 16 in the numerator. Negative 4i plus 15i is positive 11i. And in the denominator, well, I'll have 25 plus 4, which is 29. So this simplifies to 16 plus 11i over 29. In the last example, we're asked to show that 1 over I is equal to minus I. So let's go ahead and we'll do that by rationalizing the denominator. So if I have 1 over I, Well, I can multiply both the numerator and denominator by I, or I can multiply 1 over I by I over I, which is just the same thing as multiplication by 1. If I multiply the 1 times I in the numerator, I just get I. And if I multiply I times I in the denominator, I get I squared. Well, I over I squared is just I over negative 1. And I divided by negative 1 is just equal to minus I. So 1 over I is equal to negative I. That's a fun little identity with imaginary numbers. So anytime that you're asked to rationalize the denominator, and you've got the denominator written as the sum of two square roots, or you've got an imaginary number in the denominator, try multiplying by the conjugate of the denominator, either the complex conjugate, or you can multiply by the conjugate involving square roots as well. So that concludes this lesson, and we'll see you in the next video.